Hey there, ready to unlock the secrets of three-dimensional geometry? It's more than just shapes, it's the foundation for understanding our 3D world. So, what exactly is three-dimensional geometry? Simply put, it's the study of shapes and objects in three-dimensional space. It's super important for JEE because it has a high weightage and often involves tricky conceptual questions. Expect around 2 to 3 questions in your JEE main exam, so let's get started. Let's dive into our first topic, direction cosines and ratios. Think of it this way, direction cosines help us define a line's orientation in space. They're basically the cosines of the angles the line makes with the x, y, and z axes. Direction ratios, on the other hand, are proportional to these direction cosines. Okay, let's define direction cosines formally. Direction cosines are the cosines of the angles made by a line with the positive x, y, and z axes. They determine the direction of a line in 3D space. Next up, let's tackle the equation of a line. To define a line in 3D, you need a point and a direction. The vector equation looks like this, r equals a plus lambda times b, where a is a point on the line and b is the direction vector. From this vector equation, we can derive the Cartesian equation. Here's a key formula you absolutely need to know. X, x1, a equals y, y1, b equals z, z1, c, here, x1, y1, and z1 are the coordinates of a point on the line, and a, b, and c are the direction ratios. This Cartesian equation is super useful for solving problems quickly. Now, let's move on to the equation of a plane. Just like a line, a plane also needs specific information to be defined, a point on the plane and a vector that's normal, or perpendicular, to the plane. The vector equation is r dot n equals d, where n is the normal vector. Another crucial formula for planes is a, x, x1, plus b, y, y1, plus c, z, z1, equals 0. In this formula, a, b, and c are the direction ratios of the normal to the plane. Keep in mind that the plane is always normal to the vector a, b, c. Here's a key point to remember for your exam. Don't confuse direction cosines and direction ratios. Direction cosines are unique, while direction ratios are just proportional to them. Always convert direction ratios to cosines before plugging them into formulas. Let's work through a typical JEE question. Question: find the equation of a line passing through the point 1, 2, 3 with direction ratios 2, -1, and 1. Using the formula x, x1, a equals y, y1, b equals z, z1, c, we get x1, 2 equals y2, -1 equals z3, 1. So, the answer is x1, 2 equals y2, -1 equals z3, 1. Let's look at a real-world application, GPS navigation. GPS satellites pinpoint your location in 3D space, and 3D geometry is used to calculate distances and directions, helping you navigate accurately in real time. Here are a few exam tips to keep in mind. First, practice visualizing 3D shapes to really understand the concepts. Second, work through lots of problems involving lines and planes. And finally, make sure you memorize those key formulas for quick problem solving. To quickly summarize, we covered direction cosines and ratios, which define a line's direction. We also learned about the vector and Cartesian equations for both lines and planes. Remember to practice applying these concepts to different JEE problems. Want more help? Synapse offers AI-powered notes, doubt solving, and practice tests for three-dimensional geometry, all for free. Study smarter, not harder, with Synapse. Start your free learning journey today at synapse.omux.in and master three-dimensional geometry for JEE. And don't forget to subscribe to our channel for more free lessons. Visit synapse.omux.in and start learning today.